but basically this test will have 11 questions. This one is a bonus question. So you solve it, it's okay. You don't solve it, it's also okay. So basically you can earn 1.5 marks more if you solve this question. It's an extra question.
Can you explain to us?
Well, like this, yes. The function is a bit different, but it's exactly, you solve it exactly the same way. Now, yeah, so there are 11 questions out of 16.5, and the test really should be out of 15. So basically you have 1.5 marks extra as a bonus for this. Do you understand what I'm saying?
Yes.
Yeah? Okay. Now, what I will do first is I want to do some maybe 45 minutes or so of a class on polar coordinates. Then we stop for 15, 20 minutes. If you have any questions, maybe I can go through this question and explain it to you. If you have any other question you want to ask, I will be happy to answer them. Is that okay? Yeah. But first, we need to do some new material on polar coordinates. Otherwise, we will struggle later. So I want to have a look at what we call polar coordinates. Explain this to you, what they are. In general, are we okay? Can you focus on this or no?
No.
Okay. Try. Okay. Try to focus. Half an hour, maybe, whatever, and then we can stop and move into the test. Okay. So polar coordinates, in general, what you know so far, and actually I'm sure you also saw polar coordinates before. But in general, when you take a point P in the xy plane, it has two coordinates, the x coordinate and a y coordinate. Okay? xy coordinates. Which you already know. Now, we define the polar coordinates like this. Suppose you take a point P in the plane and you draw this blue line from 0 to the point P, and this angle theta here that the blue line makes with the positive x-axis, this is the angle theta, and the distance OP is r, like this. So this r and theta are called the polar coordinates of the point P, polar coordinates. So polar coordinates are r and theta. Yeah, these are called the polar coordinates. Now, x, y, r, and theta are connected. There is a connection between them. The connection is like this. Suppose you take a point P here. Yeah, this of course will be x. This side is x, and this side will be y, like this. Now, what is cosine theta? If I ask you to write cosine theta, what will it be? X over r, yeah, exactly. So x over r. So that means x is r cosine theta. That's the connection between x and the polar coordinates r and theta. In the same way, sine theta is y, the opposite side, y over r. So that means y is r sine theta, like this. And finally, the third really important rule here is that if you take x squared, if you use Pythagoras, x squared plus y squared should be equal to r squared, yes, using Pythagoras. So here are the rectangular coordinates, x and y. Here are the polar coordinates, r and theta. The connection between them is provided by these three rules, x, y, and r, the fact that x squared plus y squared is equal to r squared. Okay, so that's the starting point. All of these are important identities that you need to memorize. Example number 1, plot the points with the indicated polar coordinates r theta and determine the corresponding rectangular coordinates x and y. So r theta. So let's see what is this point. So plot it, yeah? Plot. In A, what is r? What is the value of r? 2, yeah? What is the value of theta? 0. So where is the point which has an r equal to 2 and a theta equal to 0? Theta equals 0, that means we are on the x-axis. And r is 2, that means we are here. That is the point A. Okay? Here is its polar coordinates. What are its rectangular coordinates? What is x? Look at the point A. What is x coordinate? No need. Just look where it is. Where is 2, yes? X is 2. What is the value of y? 0, finish. So the rectangular coordinates are also 2, 0. Polar coordinates 2, 0. Rectangular coordinates also 2, 0. In this case. This is just by chance, yeah. So let's have a look at B. In B, what is R? 3, yes? And what is theta? Pi over 2. So where is this point? Can you see theta equal pi over 2? That means this point is where? It's on the y-axis. Theta, 90 degrees, pi over 2. And because r is 3, that means 1, 2, 3. Here is the point B. Theta, pi over 2. So for this point, what is the x coordinate for this point? 0. Good. I can get this without using the rules, just by looking at this. X is 0. What is y? 3. So this time, rectangular coordinates are 0, 3. Now, C. What are its polar coordinates? What is R? Minus 3, negative 3. I'll tell you what this negative 3 means. And theta is pi over 2. So what happens in this case is that theta is pi over 2, yeah? So that means you go pi over 2 like this. And because r is negative, then you go to the other side and you put the point at -3. That's it. So because r is negative, so you go pi over 2, and then you go to the other side of the origin. So you go to the other side of the origin. In this, so in this case, x will be 0, yeah, and y is -3. By the way, we can find this if you wanted to use the formula. X will be r cosine theta, so r is -3 cosine pi over 2. You will see that this will give you 0, and the y is r sine theta, so it's -3 sine pi over 2, and this will give you, the y is -3, like this, and that is basically our rectangular coordinates, 0, -3. And finally, there is a D. The point D, what is r here? 2, and theta is pi. Where is this point? The negative x-axis, huh? And what is its distance from the origin? 2, yeah, because r is 2. So what will be the, so for D, I can just write, what do you think x will be? -2, huh? What is y? 0. That's it. You can check by using the rules, x equal r cosine theta and y equal r sine theta, like this. So this is what we did here. What we did in this example is we took some polar coordinates, like here, and we changed them into what? Rectangular coordinates. What are when I say rectangular coordinates, what are these? X and Y, that's it. So you have X, Y, which we call the rectangular coordinates, because you can see they give you a rectangle here, X and Y, so it's kind of a rectangle here. And so we took some polar coordinates and changed them into rectangular coordinates x, y, like this. And you can see that generally these are completely different. Polar coordinates in B, for example, polar coordinates 3 pi over 2, rectangular coordinates 0, 3. So they are completely different. Now this time, the opposite. What happened? Find the polar coordinates of the point 1, 1. What does that mean? Find the polar coordinate. R and theta. Yeah, that's it. So I want to find R and theta. So, yeah. Let me just see where this point is. It's the point 1, 1. So 1, 1. So here is the point P. 1, 1. So I want to find the angle, the R and the theta. What is R and what is theta? Now, to find R, what we can use is R squared is x squared plus y squared. So we can use that. That means it's going to be 1 squared plus 1 squared. So R squared is 2. Yeah, R squared is 2. That means R is square root of 2, or maybe minus square root of 2. It could also be negative. Yeah. So, and the theta, so let me do this first. Theta is, you can use the rule of tangent minus y over x. Very good. Okay, y over x. So this will allow you to get the value of theta. So it's going to be tan minus 1 of 1 over 1. If you put this in your calculator, it will give you pi. Can you try it? Pi over 4, yeah, 45 degrees. If you are in radians, it's pi over 4. Okay, now that means I can say that R will be, there are different, by the way, the polar coordinates are many polar coordinates. So first, I could say R is square root of 2 and theta is pi over 4. These are polar coordinates, yeah, of the point 1, 1, yeah, 45 degrees, square root of 2. Another representation is to say R is minus square root of 2, but this time theta will be on like the other side. This will be the full theta in this case. So theta will be the pi over 4 that you find before, and you add to it pi, exactly. So that means it's going to give you 5 pi over 4, like this. So this is another polar coordinates, if you want. You can check that, for example, x equal, if you use this, r cosine theta, square root of 2 cosine pi over 4, what should we get? What was the x? 1. Check. You will see that this will give you 1. Yeah? And y, in this representation, r sine theta, so square root of 2 sine pi over 4, will also give you 1. In this representation, x will be minus square root of 2 cosine of 5 pi over 4. Check this. Check your calculator. Again, you should get 1. Yeah, you should get the 1. So it's okay. And y is minus square root of 2. What? Sine this time. Sine of 5 pi over 4. And again, it's going to give you 1. So polar coordinates, okay, square root of 2 and pi over 4, fine. Also polar coordinates, minus square root of 2 and 5 pi over 4. Also polar coordinates for the same point, 1, 1 in rectangular coordinates, like this. So you can do that. So that's the way we do it. First, you find r squared by using x squared plus y squared. Then you find theta, 1 theta. And from there, you can find different polar. I could even add the 2 pi to this and still get polar coordinates. Okay, now I think same idea here. Find a polar coordinate representation for the point 2, 3. So let's do one of these. Okay, so I want to find r and theta. I want to find all polar r theta. I want to find. So what did we do? Do you remember what we just did? What's the first thing? R squared, yeah? First we write r squared, which is x squared plus y. I'm doing A, yeah? I will leave you B to do it yourself. A, so this will give us 2 squared plus, so this is going to be 13, huh? 13, okay. And then the second thing is I will find the theta, which is tan minus 1 of 3 over 2. Take your calculator.
56.
If you use radians, yeah, in radians, 0.98, yes, 0.98 radians. Okay. From this, I can, are we okay? No, this is r squared. Yeah, and at the moment, I'm just writing r squared. Now, there are different possibilities. Number one, I can take r equals square root of 13, and theta will be 0.98. This is a polar representation. I can check. What can I do to check? If I want to check, I can write x will be square root of 13 cosine 0.98. This should give me how much? The 2, yes. It should give us something very close to 2. It's not going to give us 2 exactly because the 0.98 is only an approximation. So check that you will get something very close to 2. And what is the y? Square root of 13 sine. And this should give you roughly 3. Yeah, check it. Okay. So this is one way of writing the polar coordinates. These two things, r and theta. But this is not the only way. What is the other option we have? Negative. R will be negative square root of 13, but this time the theta will be 0.98 plus pi, yes, plus 3.14. That means 4.12, sir. And I can check again. I can check that these are really true polar representation of the point 2,3. By how can I check? X minus square root of 13 cosine 4.12. Check it. It should give you again something very close to 2. Very close to 2. And the y minus square root of 13 sine 4.12, very close to 3, like this. So that is I found 2 coordinate representations. I can find many more if we want by adding pi, 2 pi. I could take 0.98 plus 2 pi. That's another representation. So because we just go around the circle. Okay, now I think we just a couple more things I want to add here. Okay, this is fairly easy. You have the rectangular coordinates. Find the rectangular coordinates for the polar coordinates which are given. So in A, what is R? 3. Yeah? What is theta? Pi over 6. So we want the rectangular coordinates. What does that mean? X and Y. Yeah? You want X and Y. Very simple. So X, we know that X is R cosine theta. So it's very easy. Just substitute. Yeah? And the Y will be R sine theta. So 3 sine pi over 6. And you find the answers without too many problems. I think these are the numbers you get. Yeah? B, I will leave you to it. You can do it without too many problems. Okay. Now, the next thing is how to graph equations which are given in polar coordinates. Yeah, we know that, for example, if I give you x squared plus y squared equal to 2, and I say graph this, what will be the graph of this equation? It's a circle, yeah, of radius square root of 2. Yeah, that's okay. We know how to graph when we have equations like this in rectangular coordinates x and y. But how do we graph r equal to 2, for example? Where are the points which have their polar coordinates r equal to 2? Well, we can do this in several ways. We can change this into x and y. What is r? R, remember, x squared plus y squared is r squared, yeah? So that means if I want r, in general, r will be the square root of, but maybe positive, maybe negative, we don't know, yeah? So r is something like this. So I can replace this here. So I can put plus or minus square root of x squared plus y squared is equal to 2. And then I will square both sides. So that means x squared plus y squared is equal to 4. Now, what is this equation? It's a circle of radius 2. That's it. So we can then graph this. I want to graph. So the graph will be just circle of radius 2. So that is, yeah. And in fact, you can see that if you take any point on this circle, what is the r here? 2, that's it. So r is equal actually to 2 on this point. R is equal to 2. Now, how about theta? Where are the points which have a theta equal to pi over 3? So this time, what do you think this will be? If you think of points which all have a theta, that angle equal to pi over 3, where are these points? Plus or minus?
Yes.
Not exactly. What shape do you think this is? Think of some points which will have a theta, the coordinate theta equal to pi over 3. What pi over 3 is how many degrees, by the way? 60 degrees, yes? So basically, what you have is, for example, this point. What is its theta? This point has a theta of pi over 3, yeah? How about this point? Also pi over 3. What is changing between these 2 points? They have the same theta, but what is different? The r is different. How about this point? What is its theta? Pi over 3. So these points which have a theta equal to pi over 3 are on a line. They are on a straight line. They are on a straight line. So you can say the equation of this green line is theta equal to pi over 3. Every point on this line has a theta equal to pi over 3. On this side, the r will be positive, but on this side, the r will be negative. But the theta is still all over the line, the theta will be pi over 3. For example, let's say I want you to graph theta equal to 0. Graph this. What do you think this is? It's exactly the x-axis, yes. This equation describes exactly the x-axis. Every point on the x-axis has a theta equal to 0. If I say theta equal to pi over 2, this is exactly the y-axis, and so on. Do you understand it? Yeah, like this. So theta equal a constant is always going to be a straight line. Yeah, this constant can be 0, pi over 2, it can be 1, 2, 3, whatever it is. So the equation is like that. Okay, let me just go back a little bit. Okay. Finally, let me finish with this example here. I want to sketch, here is an equation given in polar coordinates, yes? R and theta. I want to graph it. What is it exactly? Is it a line? Is it a circle? What is this? Okay. To do that, what we often do is I want to change this from polar coordinates to rectangular coordinates x and y. So basically, what we're going to do is sine theta. Remember, sine theta was y over r. So, do you agree? Yeah. At the beginning, we said sine theta is equal to y over r. So if I start with this equation, then I can change it into y over r, which means r squared is equal to y. Yeah. Now, what is r squared? X squared plus y squared. So basically now I've changed my equation in polar coordinates into an equation in rectangular coordinates. And this equation, I can graph it. I can handle this. Let's take y to the other side. Then, I don't know whether you remember, how did we change this? Look at the number in front of y, which is 1. So you take 1 and you divide it by 2. And then what do we do with this number? We square it. We get 1 over 4. So you take x squared plus y squared minus y, and you add 1 over 4, and you subtract minus 1 over 4, and make this equal to 0. So this is completing the square. You may know this. So what we get is x squared, and then these 3 terms are y minus 1 over 2 squared equal to 1 over 4. So our polar equation, I changed it into this equation. Now, can you see what this equation is? It's a circle. Where is the center of this circle? 0, half. 0, half. What is its radius? Square root of 1 over 4, which is also half. So basically now I can graph this. So this is a circle. The center is the point 0, half, and its radius is the square root of 1 over 4, which is half. So I can graph it without any problems. So the center is here. This is 1. So the circle will be here. Like this. So that is basically the graph of this equation. And that is the end of this for today. Okay, so we will save this. Yeah, so let me go through this question, which I said was like a bonus question for you, if you do it. So the way you do these questions is, so you have a function f here, which is defined on this region between the line y equal x, y equal minus 3, and x equal 3, like this. And you want to find either the absolute maximum or the absolute minimum. There are basically 4 things you need to do here. First, you need to look at the critical points inside the region. The way you do that is find fx and make it equal to 0. Fx here is just 2x equal to 0, so that will give you x equal 0. Find fy. Fy is 2y plus 4, huh? Make this equal to 0, so you get y equal minus 2. This point, 0 minus 2, is x equals 0, is here, somewhere here. 0 minus 2. So it's inside the region, so it's okay. We need to find the value of the function at 0 minus 2. How do we get this minus 4? substitute in f, please, yeah? In f. So you get -4. This is the first value. Keep it there. You need it for later. Now, second step is you need to look now at what's happening on these lines, 1, 2, and 3. We can start with any one. Here I'm starting with the line y equal -3. Down here, y equal -3. That means you go to the function f, and this y, you replace it with -3. Yeah, replace this y with -3. You will get the function x squared minus 3. Take its derivative and make that derivative equal to 0. Derivative here just 2x. So 2x equals 0, so x equal 0. So now you have x equals 0 and y equal -3. So you need to find the value of the function at this point that you found. So what is the value of this? Anyone calculated this? Can you take your calculator, please? I think it's -3. No?
Yeah,
-3. By the way, you can find this value just by putting x equals 0 here. It's okay. Or you can go back to the function and do it. It's fine. Now, but you can look at the line y equal -3. So the point 0 -3 was here. You also need to consider these 2 points at the end of the interval. So you need to find the value of the function here and also here. So please substitute. This will give you 0. Is it 0, I think? This is 0, yes? And also this? Oh, no, not 0, no. 6. Is it 6? And this is also 6. 6. So these values are 6, yes. If you substitute in the function, you will get 6, yeah. 6 here and 6 here. Okay, great. Now you look at the line x equals 3, which is the vertical line here. So you go to the function, this x, you replace it with 3. Yeah, on the line x equals 3, your function will be this. Take its derivative, 2y plus 4, make it equal to 0. So you get y equal -2. So now you have the point 3 and -2. So 3 -2. What will be the value? I think here, is it 13 maybe? Yeah, this is 4. So 13 minus 8. Is it 5? 5, yeah? 5. Okay, on the line, so this will be 5. Again, if you look at the line, you also need to consider now the 2 points at the end, 3 minus 3, which we already did, and this point up here, which is 3, 3. Because it's on the line y equal x, so when x is 3, y will also be 3. So you need to consider, you need to find f of 3, 3. That one will be quite a big number, 18, 30, huh? I think 30 here. Yeah, 3, 0. Finally, the third line, on the line, the green line, which is y equal x. So you go to the function, every y, I think I replaced, yeah. Every y, you put x, so you get this function now. Take the derivative, make it equal to 0. So we get x equal minus 1, but because y is the same as x, so we have f of minus 1, and that will give us minus 2, I think, yeah? Yes. Now, look at all these values. What is the absolute maximum of this function? 30 is the absolute maximum, the biggest value, and the absolute minimum is minus 4. Yeah, you have here minus 4, and that's it. So absolute maximum is 30, absolute minimum is minus 4. That's how you do it. Now, don't waste a lot of time on it. If it comes at the beginning, you're not sure how to do it, leave it. You can come back to it later. It's simple, but it takes some time to write all of this stuff. Any question you want me to solve, guys? Anyone has a question? In any case, you have 15 minutes to check your things. I will not start the test until 11 o'clock. So, if you have any question, I'm happy to answer them. If you're okay, then it's yeah.
Can you re-explain the chain rule?
Yes, I will do that now. Yes. Um, okay. Yes, the chain rule. Let's say we have this function f of xy, x e to the power of y, and then x is given as a function of t. Could be anything, yeah, sine, cosine. Here, square root of t, and y equal t to the power of 3, yeah? I want to find the derivative of the function f with respect to t. Basically, the way you do that is you need to get 4 things. You need to get fx, yeah? You need to get dx over dt, and then you need to get fy, and you need to get dy over dt. So that's the rule, that's the chain rule. That's what the chain rule says. So you need to find 4 things. Now, number 1, fx. What is the derivative of this function with respect to x? E to the power of y. This is something you need to know, girls. I mean, this is calculus 1 stuff. When you differentiate a function, you need to know how to differentiate it. Whether it's sine, cosine, ln, exponentials, these are all something you need to know. All right, you don't leave it like this. You replace the y, yeah? You replace the y with, so this means it's e t to the power of 3, yeah? Number 1, done. Number 2, what do we need? Dx over dt. The derivative of square root of t, what is it? 1 over 2 square root of t. Done. Yes or no? Number 3, fy. What is the derivative of this function with respect to y? Exactly the same thing. X e to the power of y. Yes or no? Yes. Which means I need now to replace this with square root of t e t to the power of 3. Done. Finally, dy over dt, very easy. Dy over dt is 3t squared. Now I need to bring all of this together now. So I will say df over dt is e t cubed times 1 over 2 square root of t plus square root of t et cubed multiplied by 3t squared. After that, it's my skills in algebra here. I can put this as a common factor. 1 over 2 square root of t plus 3t squared, like this. Is this difficult? No. Sorry? Sorry, what did yeah, I forgot the square root of t here, yes. Sorry. Yes. If you put this as a common factor, what is left? 3t squared, square root of t. Is this okay? Yes. Right. Anyone has which one? Ln of? Yes. In general, basically, if you have ln, if you have the function ln, whatever is inside should be positive. Yeah? It doesn't matter what it is. Whatever it is, it has, for example, ln of x plus y minus 5. You want the domain of this function. That means x plus y minus 5 must be greater than 0. That's it. And this, in fact, is, yeah, it's kind of somewhere here. Yeah? You draw the line x plus y equal to 5, x plus y minus 5 equal to 0, and then it will be on one side, not the other side. If it is something like this, then of course you will get this. Then it becomes greater than 5, which is the outside the circle of radius square root of 5, like this. So the function len is defined when inside, whatever you have inside must be greater than 6. A bit like the square root. Exactly, except that len should not be equal. The square root can be equal to 0. Anyone has any other questions? No? No questions? Okay. A lot of, I don't know why you are asking this question, girls. A lot of you are saying, why is there is a 0 here? Why is it 0? Why do you think this 0 came from? Where did it come from? Where did it come from? Yeah. 4x squared, can you see this? 4x squared minus y. What is x? What is the value of x here? 1, yes? What is the value of y? 4. Substitute. Just substitute. So 4 times 1 squared minus 4, that will give you 0. Yeah, I got, some of you are asking about this. You should see that it's just a substitution. X is 1, y is 4. Just substitute. Your calculator will give you the answer. Yeah? And of course, e to the power of 0 is 1, so the whole thing is 8. Now, can I ask you then to put everything away, please, guys? Put all your notes. Your mobile should be off the table. Your phone should be away. All your notes. I will give you some paper that you can use. Just give you a laptop and calculator and a pen next to you. Can I, no, you cannot sit like this, girls. Can you just, can I ask you to move there, please? Move there. Yes, so that someone can sit here. Yes, move there, so someone can sit here. Yes. No, we have, there's some seats available. Can you move here, please?
Okay, this time.
Yes, just check. Whoever should come along. As soon as we see. You need the lockdown browser, yes? And make sure you choose the right test. So I wanted the practice test last time. So make sure you choose the right test. Oh, sorry. It's okay, don't worry about it. Okay, try it. Because someone did not write their name on this way.